The current calendar, 2025, is a perfect square. In n years from 2025, the calendar will again be a perfect square. The smallest possible value of n is. Well, 2025 is I believe 45 squared. Well, the next perfect square is 46 squared, and 46 squared is 2116. So we just have to figure out what is the difference there. Well, 2116, subtract from it 2025, and you get 91. So 91 is the value for n, and that would be E. In the diagram, a number is to be written at each of the vertices of the three pentagons. Some of the numbers have already been written. If the sum of the numbers at the vertices of each pentagon is to be 25, what is the value of x? So let's label it first. Let's call it A, B, and C and D. So in the first pentagon, this guy right here, the sum is 5 plus 9 plus 4 plus A plus B. And that, they're saying, is 25. So that means that A plus B would be, let's see here, 20 minus 13, 7. Correct? Okay. So apply the same principle to this guy. That would be 7 plus 3 plus 7 plus C plus D is 25. And therefore C plus D is 8, I believe. Okay, so then finally we apply it to the pentagon in the middle. And that's going to be A plus B plus C plus D plus X is 25. Now A plus B is 7, so put that there. C plus D is 8, so put that there. And therefore we can now calculate X, and X would be 10. So therefore number 12 is E. Farhan has a blue hat, blue scarf, white scarf, green scarf. He randomly chooses one hat and one scarf. What is the probability that the hat and the scarf are the same color? Okay, well, the probability of both of them being the same color, let's see. So that means they're either both blue, the hat and the scarf, or it means that, and we have to add to that the probability that they're both white. Okay. So let's start. The probability, this we have both blue. So blue hat, blue hat plus blue scarf plus the probability of a white hat and a white scarf. All right. So the probability of a blue hat, how many hats are there? There's 2 hats, right? So the probability of choosing a blue out of 2 is 1/2. And then the probability of a blue scarf, there's 1, 2, 3 scarves, so that would be 1 out of those 3, 1/3. White hat, same thing, it's a half. White scarf, I believe 1/3, same thing. So that looks to me like 1/6 plus 1/6, and that's 2/6, which is 1/3. 1/3 is the answer, and that would be A. Yesterday, 200 people bought ice cream at the Cayley Creamery. A total of 85 people ordered fudge with their ice cream. A total of 60 people ordered sprinkles with their ice cream. A total of 32 people ordered both fudge and sprinkles. How many of the 200 people ordered neither fudge nor sprinkles? So we do one of those famous Venn diagrams. Venn diagram. All right, here we go. So let me explain it. So the first circle, I am representing that to be the fudge. And the second circle, the sprinkles, right? And then the total is 200. So put that 200 out here. And then these regions I'll call A, B, and C because I'm not sure what they are yet. I think I know, but let me just label it with letters first, and then we'll talk about it. Okay, so let's go with the first sentence. 85 people ordered fudge with their ice cream. So that means that A plus B is 85. Next sentence, 60 people ordered sprinkles. So B plus C is 60. And then the 32 people ordered both fudge and sprinkles. So that basically means B. The region that's common to both fudge and sprinkles, that's 32. So that's really good. So they've given you this one. So that means you can easily calculate A. A would just be 85 minus 32, which is 53. And then similarly, you can easily calculate C. That'd be 28. Okay, so what is it that they're asking for? How many of the 200 people ordered neither fudge nor sprinkles? Okay, so I think that means that of all the people, how many are not A, not B, and not C? Okay, that shouldn't be hard. That's minus 53, minus 32, minus 28. And when you do that math, you will get 87. And therefore, the answer is C. In the diagram, triangle ABC is right angled and at B, and the semicircle has a diameter BC. If AB is 20, AC is 40, what is the area of the semicircle? Okay, so using Pythagoras, we can easily figure out the length of BC using that formula, and therefore BC can be calculated, and BC squared is going to be 1200. Okay, let's just keep that for now. So the area of the semicircle would be pi r squared divided by 2, correct? So that is going to be pi, well, the radius would be BC divided by 2. So that's going to be the radius squared all over 2. So let's see, that's going to be pi BC squared over 4 over 2. So that looks to me like pi over 8 BC squared. Okay, so continuing, pi over 8 BC squared. Well, BC squared is this guy, 1200. So therefore, it'd be 1200 over 8, which I believe is 150. 150 pi. And therefore, that's D. A jar contains 600 marbles, each of which is either red, yellow, or green. The ratio of the number of red marbles to the number of yellow marbles to the number of green marbles is 7 to 3 to 5. If 20 marbles of each color are removed, the new ratio of the number of red marbles to the number of yellow marbles to the number of green marbles is. Okay, so we got 600 in the beginning, and we have red, yellow, and green. And initially, it's 7, 3, and 5. See, I don't know how many are in each, but that's why I put it in the X. But we know one thing, 7x plus 3x plus 5x equals 600. That's very nice of them to give that. So this can easily be calculated. So that's 15x is 600. And therefore x would be 40, I believe. So therefore this 7x is 7 times 40, which is 280. That's going to be 120. And that will be 200, right? And then what they're saying is they're removing 20 from each. So if you remove 20 from, let me just put that in, minus 20 from each. So this comes down to 260, this comes down to 100, and this to 180. So this is basically the ratio. But of course they want it in the lowest terms. If I divide through by 10, I'll get 26, 10, and 18. Can I go this any further? If I divide through by 2, I'll get 13, 5, and 9. And I think this is in lowest terms because 5 is a prime number, and so is 13, I think. So 13, 5, and 9 is the new ratio, and that would be C. For each non-zero real number, A, we define A asterisk as 5 over A. The expression 100 star, all star, is equal to. Okay, let's do this. 100 star, all to the star. Okay, well, 100 star, just the one inside the bracket, using this guy, would basically be 5 over 100, I believe. Right? And that is 1 over 20. Well, we have to put that star in. So 1 over 20, all star. Okay, then we use this formula again with the 1 over 20. So it'd be 5 over 1 over 20. So that's going to be 5 over 1 times 20 over 1, and that is 100. So we're back to 100 again. So therefore, the answer is A. Lavinia has one bottle with capacity 6 and another bottle with capacity 5. Both bottles are empty. She has a piece of paper with the following steps. Fill the 6-liter bottle with water. Pour water from the 6-liter bottle into the 5-liter bottle until the bottle is full. Empty the 5-liter bottle. Pour water from the 6-liter bottle into the 5-liter bottle until the 5-liter bottle is full or the 6-liter bottle is empty, whichever happens first. If the 5-liter bottle fills, empty the 5-liter bottle and return to the beginning of the step. Lavinia completes the following sequence of 4 steps in this order 3 times. Then she never spills any water. How much water will be in the 5-liter bottle after Lavinia is finished? All right. So we've got 3 steps, right? So let's see here. Yeah, I'll try to keep it in the same screen. Okay, so let's try to keep everything in the same screen because I want you to be able to see these steps here as a reference. Okay, so we got step number 1, 2, 3, and 4. And then, of course, we're going to do it once, twice, and then a 3rd time. And then at the very end, I guess the answer will be here. Okay, so here we go. So the first is we have the 6-liter, whatever it's called, bottle. Okay, and then the next is the pour water from the 6-liter into the 5-liter. Okay, so the 5-liter will be completely full, but you still have 1 liter left in the 6-liter bottle. And then we empty the 5-liter bottle. Okay, so that's emptied, but we still have 1 liter in there. And then last is pour water from the 6-liter into the 5-liter. So that's going to be empty, but then you're going to have 1 liter in the 5-liter bottle. Okay, you got it? So that's basically I went through the steps once. Now we got to go through it 2 more times. Okay, so I'm not going to talk you through it. I'm just going to write it because it's the exact same as what I did. So this is the first step. This is the second round, of course. Second step. Okay, so how much is going to go in there? 4. So that's going to be 2 left in here. Okay. Third step, we've got to empty that guy. Okay, that's an easy step. Nothing to calculate. And then we got to pour that back into the other one. We got 2 in there. Okay, let's go through this again. Last time. Fill this up. Remember, this still has 2 liters in it. Then we have to pour. So the capacity is 5, so 3 is going to go in there. So that's going to bring it up to 5. But if 3 goes in there, then 3 is still left in there. And then we have to empty this guy. Still got 3 in there. And then we have to pour that into the other one. So that's going to be 3. Okay, so how much water will be in the 5-liter bottle after Lavinia is finished? The answer is 3 liters. And therefore, that would be D. In the diagram, ABCD is a square with area K. Point E is on the side AB with AE equal to AB over 3. Point G is on the side BC with BG equal to BC over 4. Point F is on ED so that GF is perpendicular to BC. The area of triangle FGC is. Okay, well, let's interesting. They don't give me any numbers, right? They just give me this K. I'm going to, I want this to be easily understood, so I'm going to give K a value. And let's see here. Since they're using thirds and fourths, it's got to be divisible by 3 and by 4, so it has to be divisible by 12. So I'm going to give it 144. I hope you understood why. So if K is 144, and I'm going to label the side as X, and this is a square, right? Yeah. So that means X squared what is K actually? Oh, the area. Yeah, that's what I thought. X squared is K, which is 144. Yeah, forgot. It's in the first sentence, so I forgot. Okay, so there we go. I think if there's a number, it'll just make it a little bit easier. Otherwise, it becomes abstract and it might be more difficult to understand. Okay, so let's go with this. AE is 1/3 of AB. So if X is, therefore X would be 12, right? So if X is 12 and AE is 1/3 of that, so 1/3 of that would be 4. So AE is 4, and then therefore EB is 8. And similarly, this guy over here, BG is 1/4 of BC. So BG would be 3, and then GC would be 9. Okay. And what do they want? The area of FGC. FGC. Okay, so that's going to be 1/2 base, which is GC, times height with the FG. Okay, so that's 1/2 GC. We have 9. Oh, but we don't have FG. Okay, so I got to figure out what FG is. Okay, shouldn't be too hard. From B to G, you're going 1/4 of the distance from B to C, right? So similarly, when you go from E to F, it would be 1/4 of an increase in height from A to E. Does that make sense? So let me use a different color here. So when you're going from E to F, it would be 1/4 of the height from A to E, and 1/4 of that, 1/4 of 4 is 1. So that means that little distance in here is 1. So it would, from F to G would be 9, because you have to add this 8 with that 1. So there we go. So we have 81/2. But all the answers are in K, so I've got to go back and put a K in there. So how do I do that? So that would basically be, I'd have to, I got it. So something times K is 81/2. Yeah, and then K is 144. Okay, I understand. So N would be 81/2 times 144. And I got to put this obviously in lowest terms. And I think in lowest terms, it's divide top and bottom by 9. So you get 9/32. 9/32, K, right? Because it's NK. So N is 9/32. So 9/32K. There we go. And that matches A for number 19. In the diagram, line segment CD has length 48. Two ants, Violet and Petunia, are at point C and will plan to walk to point D. Violet walks along 4 congruent semicircles above CD. Petunia walks along 3 congruent semicircles below CD. Violet and Petunia start walking at the same time, and they walk at a constant but different speeds. Petunia arrives at D 12 seconds before Violet and travels 3 times as quickly as Violet. How long does it take Violet to walk from C to D? Let's try to keep the diagram in the screen. So CD, they have told me, is 48. And then we have Violet and we have Petunia. And we use that standard formula, speed equals distance over time, throughout this question. And let me first, I've got to figure out a few things here. I've got to figure out the distance. So I'll do it up here. For who's going below? Violet, let me think about this for a second. Violet walks along 3 congruent semicircles below CD. Right. So Violet's path is below CD. Okay, I got it. So if Violet's path is below CD, no, sorry, Petunia. Petunia walks along 3 congruent semicircles below CD. Okay, so let's put Petunia over here. So Petunia, we have to figure out how long she actually travels, the distance. So first we have to take this 48 and divide it by 3 to get each segment. I guess the diameter is what we're trying to get, and that's going to be 16. So the diameter is 16. Now the circumference is pi times the diameter, so the circumference would be 16 pi. So she's traveling half of the circumference 3 times, so 3 times c over 2, which is 3 times 16 pi over 2, so that's 24 pi. So 24 pi is her D, this one right here. That's for Petunia. And then let's go back and figure out, Violet walks along 4 congruent semicircle paths above CD. Okay, I got it. So for Violet, it would be 48. We've got to divide that by 4 to get the diameter. That's 12. And then similarly, circumference is pi d. So that'd be 12 pi. And then violet is traveling 4 of those semicircles. So that's 4 times c over 2. So that's going to be 4 times 12 pi over 2. And that's 24 pi also. Oh, okay, I didn't expect that, but that's fine. I believe it. So that takes care of the D. So we got one part of that question solved. And now we have to proceed to the next part. Okay, so the next part, we have to interpret the next few sentences. So they're saying they walk at the same time constantly, but different speeds. Okay, so different speeds. So the speed of Petunia is 3 times the speed of Violet, right? Petunia travels 3 times as quickly as Violet. Okay, that's a correct interpretation. And the time of Violet, Petunia arrives at D 12 seconds before Violet. So the time of Violet, the Petunia's time is shorter. So that means time of Petunia would be Violet's time minus 12. Right. Okay, and then now we just plug these in. And plug these into the equation, this equation, and then see what we can get. And what are we trying to get here? How long does it take Violet to walk? So we're trying to get the time for Violet, TV. Yeah, this guy right here. Okay, it shouldn't be too hard. Let's see what happens. So, using this standard equation, we would get that TV is equal to D over S, right? Now the distance is 24 pi, and the speed, well, we don't know the speed, it's just, I've labeled it SV. All right, well, let's proceed with something else then. We've got, over on this side, these things will give me, using this formula, would give me the speed of, let's see here. Speed of Petunia is the distance of Petunia over the time for Petunia. Now the speed of Petunia is 3SV, and then the time for Petunia is this guy, TV, over minus 12. Yeah. Okay, then I can plug one into the other. Okay, I got it. I knew there had to be some sort of correlation eventually. Okay, I'll plug one into the other. So first, let's solve for SV, 24 pi over 3 times TV minus 12, and then I can plug this guy over here. Okay, got it. So, because TV is what we're trying to figure out. So 24 pi over 24 pi over 3 times TV minus 12. Okay, so 24 pi over 1, invert and multiply, 3 times TV minus 12 over 24 pi. Those 24 pi's cancel, and then we just get left with 3 TV minus 36. 36 equals 2 TV, and therefore 18 is equal to TV. There we go. See, it all worked out in the end. So TV is 18, and therefore that would be, where's 18 here? B is the answer.